Hi, my name is Eunice,
And my name is Yusuf.
and we're going to be presenting our ECE 285 final project. The task that we set for ourselves is image generation of pictures of mosques. So our goal is to basically, or next, sorry. Oh,
Fam.
this is not working, bro. Cause okay. Start again. When I say next, then you're going to basically move it to the next slide.
Yeah, basically. And then you'll just follow
So
along.
so I said okay, okay.
Okay.
From the top again.
All right. No worries. Hi, my name is Yusuf.
And my name is Eunice, and we're going to be presenting our ECE 285 final project. In particular, the task that we set ourselves to is to do image generation using deep convolutional GANs. Next. So in particular, the goal of our project was to create an image generation model that can generate pictures of mosques. And also, so part of the model that we're building is that we're going to be essentially having a generator and a discriminator that are kind of doing adversarial training to basically have the generator try to uh, improve the quality of its images via some feedback loop that comes from the discriminator. Now, talking about the data set that we obtained, it was a relatively small data set. It was only around 13 images. And we had done a 70-30 split for where we have 70% of the data for the training data set and during the training loop, and then also 30% for testing and the validation set. So looking into next, so looking into the training data set, as you can see, they are just simply 128 by 128 small images of various mosques and stuff like that. And as we can see, they all have the same label, and the thing is that they have a lot of different variety, right? So some are in the night, some are in the day, some have minarets, some have domes, some are smaller, some are larger. So we are hoping that our model can kind of pick up on these differences through the image and then be able to recreate this distribution from which the data is coming from, right? So kind of talking about how we did it, or let's go to the next slide. How we did it. We the model that we used was deep convolutional GANs. Which is a very effective tool in image generation because it kind of combines the GANs, which are really good for AI generation, with convolutional layers, which are really good for learning spatial information from images. And kind of the main thing that we experimented with was different epochs, learning rates, and kernel sizes. So messing around with kind of how long we trained the model for and the architecture and stuff like that. We wanted to try to find the set of hyperparameters that would produce the best possible images for us. And as I mentioned before, the mosque images were around 1,300 in number. Now the original size was 160 at 128 by 128, but we decided to clip it down to 64 just to make it a little easier for computational sake. And so that way it's a little easier and faster to run. Next.
So for the generator, we decided to do a 5-layer deep convolutional neural network where we had transposed convolutional layers. We used the ReLU activation as it was something that we are more familiar with. And of course, we did batch normalization because we wanted to upscale the input noise to 64 by 64 images. And of course, that would be to get rid of extra noise that we have and of course keep it all constant. We then take in a 100-dimensional random noise vector as an input, and then we create a 64 by 64 RGB image with tan activation. Then we use a kernel size of 4, as higher kernel sizes were not as effective. And actually, for this type of model, lower kernel size is more fitting and suiting. We used a kernel size of 4 for the initial layer, and then a 5 for the subsequent layers, with respective padding to maintain the desired output dimensions. And then, of course, we did backpropagation for generator loss. So for our discriminator method, once again we used the ReLU activation function as we are more familiar with that, and we had, of course, batch normalization because we wanted to be able to tell what the real images were and what the fake images were. And of course, this was a 5-layer convolutional neural network. Now, once again, we used 64 by 64 RGB images because that's what our input dimensions were, and we outputted a scalar value that would tell us what the probability of the image would be. If it's what probability the image is real or fake. So if it would be zero point 0.8, that means there's an 80% chance that the image is real. Now, of course, this involved backpropagation, and because we wanted to make sure that the parameters were updated and based on the loss, and this also helped us in order to get a big more accurate probabilities when it came to distinguishing the fake and real images. So over here we have generator results. Now this is with a learning rate of 0.0002. And of course we tried many other learning rates, but we found this to be the most effective output, where we have 300 epochs, like I said, learning rate of 0.0002, a batch size of 128, a kernel size of 5, and padding of 2. And of course we see that there is room for improvement. We do have much to be desired, but we can still kind of tell, of course, when you squint your eyes, you can see that you can tell it's a mosque. And if you put the computer far away from yourself, once again, you'll know it's a mosque. But as you can tell, it is kind of blurry, and there is much to be desired because the input images that we had were only 1,300, and that's because of the data set that we found on Kaggle. That is the one with the most images that we found. So there certainly is a demand for more images in such a data set. So that could be something in the future that we could work on, because if we had something maybe as 3,000 or 4,000, even 16,000, which are like standard in data sets, it would have had a much higher quality in our output. Now here we have a side-by-side comparison, the real images with the fake images. So as you can see, they do look quite similar. If you looked at the ones on the right, you would probably be able to guess that they are mosques indeed. But like I said before, if we had more input images and if we were able to do some more model tweaking, of course we could be able to get much more higher quality images. Thank you for listening.